Sure. All right. Well, welcome to the last day in the review. I want to start by going over the quizzes that you just turned in. Hopefully everybody got a chance to turn them in. I will have them graded this afternoon. No way around it. I got to get that stuff done. But you'd like to know the keys are posted, so there's not really a whole lot going on. They're fairly simple. The question that I was getting asked mostly was problem one of quiz 25. So I want to remind you how to kind of look at that. So I want to look at a Calc 1 problem just really quickly. If I said, find the area below, below the curve y equals f of x. Let's just say that's the question. And we'll keep it simple over the interval a to b. So here's the problem that we did in Calc 1. When we say quote unquote area below the curve, we always mean from the curve to the x-axis. That's why if the curve is actually below the axis, you will get a negative value for the integral. So this integration is pretty simple. It's just this. Okay? Below the curve means from here to the axis. Now, if I change the problem and I say find the area now bounded by y equal f of x and y equal g of x, and let's suppose they actually intersect. That makes it easier. Maybe I have a line and a parabola or something. So there's, let's say, there's my y equals f of x, and let's say, I don't know, there's my y equals g of x right below it. If I don't give you the range of x values from a to b because they actually intersect, again, the simplest example we like using in Calc 1 is we take parabolas and lines. I have a clear region here. This is no longer the area under f of x because it's certainly not the area under, it's the area between. So in this case, or you could also say top one minus bottom, but the bounded means this. Bounded means you are enclosing something, and I know that this one, therefore, looks like f of x minus g of x, because in my picture, f of x is always on top. So then there's one other possibility, one we don't like in Calc 1, and that's when we do something like, let's say like a sine wave. Right now, the sine wave is on top. Right now, the sine wave is below. If I wanted to find this total area, this would require two integrations, because in this case, it's curve to axis. In this case, it's axis to curve. If I do curve to axis, in this case, I'll get a negative quantity. But if I want those two positive areas, I have to actually break this up into two integrals because my boundaries changed. Top and bottom switched places. So now we're looking at a polar graph. And I'm hoping people actually drew the graph, because if you try to do this in your head, that's probably not a good idea. And the curves were r equal 4 and r equal 4 minus 4 times the cosine of theta. So r equal 4 would be the circle of radius 4 centered at the origin. This guy's the sideways opening cardioid, but it's going to open, it's going to go mostly that way because of the minus. Quick check, if theta is 0, I'm at the origin. If theta is pi, I'm way over here. So this one's going to kind of go like this ish. Okay. Now, when I say, if I said area bounded by the cardioid, that would be this part here. If I said area bounded by the circle, well, that'd just be the area inside the circle. If I say area bounded by both shapes, just like we did in the XY plane, it's the area that's inside of both of them at the same time, the intersection. So does anybody want to tell me, how would I describe this region over here? How would in words, how would I describe this region right here to the right of the cardioid? Anybody want to try that one? Because I said that was a possible answer. In fact, I don't know if that's the one we did the other day.
It's inside the circle, but
Keep
outside
going.
the other one.
Perfect. Inside the circle and at the same time outside the cardioid. If I just said outside the cardioid, that's the whole plane that goes forever and ever. That's infinite. So we don't just say outside of a shape, because outside of a shape would go forever. So Yaman said it perfectly. Outside the cardioid, inside the circle. Then what would this region here be?
Inside the cardioid, outside the circle.
Yeah. So if I'm bounded means I'm inside both. That's it. Now, there's a couple of ways you could set this up. You could start by being really, really lazy, because
I think
that's just a semicircle, isn't it?
that's what I did. I got that
Technically,
semicircle.
yeah, technically, do I have to integrate to find that side? I mean, I can just for fun. Do I have? But that's a semicircle.
I did.
I just say it's a semicircle and go with that? Sure. But if, let's say you want to be formless, I want to do the integration. Okay. Well, we showed last time that's pi over 2. That point right there corresponds to an angle of pi over 2. Because pi over 2 on my circle, I'm here, and 4 minus 4 times the cosine of pi over 2 also puts me here. And then I know that one would be 3 pi over 2. You could also call it negative pi over 2, depending on which direction you want to travel. So if I want this area and I want to do it from an integration standpoint, then I would say, and let's make it simple. Let's call that area 1, and let's call these pieces area 2. Because I have to do 2 separate integrations. Why? Because on this side, I'm bounded by a circle, and on this side, I'm bounded by cardioid. I cannot do that as one integral. It's not possible. The other thing is my limits of integration for the left side are not the same as my limits of integration for the right. So if I was going to do A1 as an integral, remember it's 1/2 r squared. So it'd be 1/2 4 squared d theta from pi over 2 to 3 pi over 2. And that's going to be half the area of a circle. That's pretty simple. Now, what about area 2? Oh, that's going to be 1/2 4 minus 4 cos theta. These parentheses. Quantity squared d theta. But what are my limits of integration? This would be from 0 to pi over 2. And then from 3 pi over 2 to 2 pi. That means I'd have to do 2 integrations. Can I do this with 1? Can I be clever? I said a moment ago.
Just do it once and multiply the answer by 2.
Okay, hold that thought. That's, by the way, that's the most genius of all. But what if I want to do this whole thing as one integration?
Oh, from like negative, can you do like I doubted that I could do this from negative 3 pi over 2 to pi over 2, but I didn't want to mess with that.
That is correct. Oh, because it's got to be increasing. Because in terms of a position, if I'm going this way, I'd call it 3 pi over 2. But if I was going backwards, I'd call it negative pi over 2. This is absolutely correct. But I like what Yaman said a moment ago. Because of the shape, won't that area right there be exactly the same as that area right there? Does everybody agree with that? That those 2 areas should be exactly the same? What do you think? Yes? No? Maybe?
Yes. Yeah, they are.
Yeah. So could I just go 0 to pi over 2 and then double the whole thing? Would that be legal?
Yeah.
Yeah, and it'd probably be the least amount of work. It's still going to be work, but it's going to be less work. So this was just half of the circle. This is pretty easy. So this is just 8 pi, because that's half of a circle. This one looks exactly like what we did last day. I have to square it, I have to use my double angle formula, and I have to go from there. But the number one question I was getting asked through email was, when I'm looking at this, I'm guessing people were graphing it correctly, which is the region that is bounded? So bounded means it has to be inside as opposed to outside. So again, I would use, and I like the way Yaman explained it, if I want this region here, or this region here, I have to use different words, inside of one, outside of the other. This is the only part that's inside of both simultaneously. So that means my 2 shapes both serve as boundaries. So that's the language we always used in Calc 1, bound by the curves. Question.
I have a question.
Sure.
So wouldn't the
area of the cardioid and from the left half, and the area of the circle on the right half also be the area bounded by the two shapes?
Well, no, because this area is outside the cardioid. The cardioid is no longer a boundary for this one. To be
But
a
if you
boundary, you
ignore
have to be
everything,
inside.
if you ever ignore everything in the pole, so you just have this unusual, almost sideways figure 8 shape, then you have both bounded by each other. If I'm making any sense.
I'm not sure. You may be making sense. Your language that you're choosing is a little bit. Do we all agree that with the two shapes simultaneously, there's really 3 different regions?
Yes.
This region, this region, this region, but only the middle one are both shapes serving as boundaries. Remember, over here, you're completely outside the circle. So we wouldn't say bounded by the circle, we'd say outside the circle. This region here, we are bounded by the circle, but we're outside the cardioid. Remember,
All right,
outside
then,
of a shape goes forever. So.
then how would you describe the sum of all 3 areas?
Oh, that's a great one. There's a word here that we don't typically use in this. What word did I use to describe this? There was a word I said when you had your 2 shapes, and this was the
Overlap?
Intersection.
It was the intersection of the 2.
So
if you wanted all of this, there's a different word. What's another word that goes with intersection? It would be the
outer section. Oh.
Anybody? I know Tom knows it because it's a set theory logic kind of the union.
Oh, yeah, the union.
That's, by the way, that is the only term mathematically that you could use to describe all of it at once. And whenever you're doing a union, here's the danger. I calculate the area of my circle and then I add it to the area of the cardioid.
No.
Why would that not be correct?
Because there's common areas between them.
Because I counted this area twice. So this is one of the things, by the way, the only place you really have explored this in the past would be maybe a stats course. So by the way, it's a great question. How do I figure out all of them? Because if I simply find the area of my circle and I add it to the area of my cardioid, it's too big. So what you would do is you'd subtract out the intersection because I counted it in the cardioid and I counted it in the circle. That's not a question I'm going to ask you just because that's a little over the top. But it's a great.
So this question confused me a lot. I was very unclear on what you were asking. So I found the area of all 3 sections and also added them together to cover all my bases.
So you did more work than I really needed to.
Yeah.
It's not even about the answer to the question. It's understanding how to set up a polar integral. That's really what it comes down to. It's interesting though, because the term bounded by has absolutely one interpretation. It's not vague in any way, but if it's not a term you've been using or you're used to seeing, then there's where the misinterpretation comes from. The word, it can't be interpreted any other way. Yet, if we haven't been doing it, again, I mentioned this last day, I said, when I draw this picture, there's 3 different regions we can find. I haven't seen a situation where you'd be asked for all of them, because generally when there's more than one graph, the only part you're ever interested is in the intersection, the part that's completely bounded by. And then that we get into some trouble when we're not looking at the right thing. In Calc 3, we look at these same kind of problems, but we do them in 3 dimensions. So now I've got 3-dimensional things and I want volumes instead of areas. But now it's trickier because you have to start thinking in 3D. So we use the same logic. Again, don't beat yourself up if you set it up incorrectly. I'm still giving you, I'm looking at what you did setup wise. Most of the stuff here is just not that taxing. And we already know the nature of things. Now, final exam. Okay. This question comes up in every class you've ever had. Okay. What's on the final and how much is the end of the course weighted? I have had courses. I've had graduate courses at San Diego State in statistics. I remember one of the best courses I ever had. We had an exam after week 6, we had an exam after week 12, and then we had a final exam. Our final exam, 80% of it was the material taught the last 2 weeks of the class, and the final was 60% of the grade. Now think about that logically. 60% of your grade is the final exam, 80% of the final, that now makes it 48% of your grade for the entire semester was the material taught the last 2 weeks of the course, because it wasn't on any exam. So the instructor decided to make it most of the final, which was most of the grade. Each midterm was 20% of the grade. So the first 80% of the course only counted a small amount. The last 20% of the course was actually most of the grade. And I remember we had a couple of students in the class that didn't make it much to the last couple of weeks. They were doing very well. They failed the class and of course were kicked out of grad school. You can't fail courses in grad school. You can't actually get C's in grad school. They were kicked out. And I talked to the instructor, and brilliant instructor, great instructor. And I talked to him, it was a 2-semester course. I said, maybe you ought to change the way you weight your final. He goes, what do you mean? I said, well, if everything in the course is equally valid, you can't make the final exam everything that wasn't on an exam, because you just made that the most important part of the course. Yet it was the only stuff you didn't say was important enough to put on an exam. Yet now it's the whole grade. I said, that doesn't make a lot of sense. And he said, yeah, you're right. And thing was, he retired at the end of that the next semester. So he never got a chance to fix it. Everything we've done in this course is equally weighted. We've had 25 lectures. So if you think about it this way, if I could take only one question from each class, only one, that would be final exam worthy. And that's kind of the way the final is going to look. Quite literally one question from every class. One class doesn't get 2 or 3 questions, and then 2 or 3 other classes get no questions. You see, that wouldn't make a lot of sense. So everything's essentially equally weighted. We had a couple of lectures that didn't show up on an exam. Otherwise, we'd be taking the last exam, right before the final, like the day of the final. No, there's always got to be material that doesn't show up on an exam. So you have a gap before the final, but that last material doesn't all of a sudden become more important than everything else. That's what the last quizzes were for, so that you would have at least been quizzed on every single topic that's fair game for the final exam. So every question on the final you have seen already on a quiz or an exam or both. But there won't be any questions you haven't seen, but there won't be any questions you're going to see multiple times. Okay, so I want to make sure everybody understands that part. Now, right now, if you go to Canvas, all of the scores in the course are on there except for the last 2 quizzes. I'll get those hopefully, this afternoon at some point. I have both classes to contend with. I just got finished grading the exams. That was my priority. So right now, so that you know exactly where you stand and there's no ambiguity, there's 2,550 points in the course. So far, if you go to Canvas and you look, it will say there's 2,490. There's still 60 more points, the last 2 quizzes, of course, that will be applied. It has your percentage. Don't go by your percentage, go by your total points, because again, we haven't got the last 2 quizzes. And I think we just did this. I think it's 2295 for an A, and I think it was 2040. Yeah, I think that's what it was for a B. I think that was the numbers, if I remember, because I just did this. Right now, if you go onto Canvas and you go all the way to the far right where it has your percentage, if you put the cursor on that, it will actually give you the quotient that produced that percentage. The numerator of the quotient is your total points in the course. Now, there's still 60 more points that have to be applied. And if you turned in your last 2 quizzes, then hopefully you got most of that, okay? If you've already reached any of these thresholds in that numerator, that means you're absolutely guaranteed that grade. You can't somehow go backwards from that point. If that grade is an A, then you've already got an A, and so on. Now, what if that grade's a B or a C, or not even a C yet? Well, that's where you're going to take the final to raise your grade. And so your best 20 quizzes and your best 2 exams, which you can just go look and see what that is, okay? Look at your worst quizzes, look at your worst exam, and deduct that from your total points. Now, the difference between that and any one of these thresholds is exactly what you must do on the final, except that you still have those 2 remaining quizzes that, of course, should raise your grade significantly in terms of the total points. If you are less than 60 points from any of these thresholds and you turned in those last quizzes, you could still make it based on the quizzes. That's why I'm going to make every effort to get those grades out to you as soon as I can, so that you can make an informed choice. But if you've already reached these thresholds, then the quizzes aren't going to change anything. Okay. Now I do want to remind people, because this always comes up, the final is optional, but it would be foolish not to take it if you haven't already earned an A, because otherwise you won't be able to raise your grade. If the final exam isn't better than your worst exam plus your 5 worst quizzes, if the final doesn't exceed that total, then the final is the dropped grade, in the same way that if you don't take the final, you get a 0, and then that's your dropped grade, because you're dropping your worst 750 points, which is of course the equal value of the final. So if you take the final and it exceeds your worst scores, then the final is raising your grade. If it doesn't, then your grade didn't change. It's as if you didn't take the final. So there's no penalty whatsoever. Final is only there to raise your grade, not to say, well, some cases it might be there to save your grade, but that's a little more stressful. So if you are happy with your standing, you said, oh, I got the grade I want, great. I would ask you to send me an email. Don't tell me in person, I won't remember. Just send me an email and just say, I am not going to take the final. You don't have to give me a reason. You just say, Mr. Brown, I'm not going to take the final. That way I'm not expecting you tomorrow. And as I told the other class, I'm expecting every single person is going to take the final unless they tell me otherwise. So when I don't see you showing up and I didn't get an email, I'm wondering, where the heck are you? You know, and I'm worried. And many of you have received an email from me during the exam at the beginning. You know, we're 10 or 15 minutes in the exam, and there's always people that haven't shown up, and I'm emailing them saying, where are you? Is everything okay? And everything's not always okay. And sometimes they get back to me. I've gotten some pretty funny excuses this semester. The favorite one was in the other class, on the second exam, I emailed somebody, said, where are you? They finally emailed me back the next day and said, oh, I thought the exam was on Saturday, like all of our other exams have been. We'd only had one exam and it wasn't on a Saturday. Yeah, that was one of the weirdest I had ever heard. Why, you know, and it's not like we don't have a schedule, and we've been reviewing and talking about it and setting up. And I sent you multiple emails, and I emailed them to find, you know, that exam, you know, that morning. They never checked anything. So we will start at 10:15 like we always do. We'll have 2 hours like we always do. Nothing's going to be different in that regard. And the final exam will be more questions than you have to do, like the other exams. The biggest difference with the final, though, is the fact that the questions come from everything we've done this semester. So that's automatically more difficult because you have to remember all the stuff we've done. So then the other thing that's going to be different about the final is, right now you have done formula cards for each exam. Okay, you did 3 formula cards for each exam, and people ask, well, can I bring those to the final? Yes, but don't. Start from scratch. You see, it was in the creation of those formula cards that you were forcing yourself to review all the theorems, formulas, definitions, you know, making sure you had everything down. When you wrote those down, you reinforced them. If you don't write them down and they're just already there, then you're not really getting the review that they were meant for, especially the ones that are older. So start from scratch. But the other thing is, you may bring an 8.5 by 11 sheet of paper, one side, and write your theorems and formulas and definitions, because I guarantee you there's things that you wrote before that you'll say, no, I don't need to put that. I've got that. And probably there are things that you should have wrote and you didn't that need to make it this time. One side of an 8.5 by 11, I can't imagine you could fill it up, although some of you might actually fill it up, and bring that to the final exam. Yes, you can bring your original note cards, but again, it's the reorganization, it's the remaking it that really reinforces everything for you. And there are certain things that some of you need to write down because maybe you didn't write them down. There were a few places on this last exam, for example, that people actually wrote the wrong formula. Like, for example, the cotangent of 2 phi formula actually had some incorrect formulas. That's kind of dangerous. Well, that obviously meant incorrect conclusions or incorrect ways of coming up with certain things. You know, so make sure that you take the time and trouble and attention if you're taking the final. Again, if you're not going to take the final, a simple email is all I need. Okay.
I made that mistake, by the way, Professor.
I'm sorry, say again, Tom.
I wrote down a formula wrong on my a note card, and then during the exam, obviously, I'm not thinking about writing a formula wrong. And
Yeah, nobody does. Nobody does. If we were in class, which we will be in a few weeks, if we were in class, one of the things I always stress to students, you're sitting, you guys are really good about working together and consulting and talking and stuff. So I would say, all right, here's what everybody should always do. So Tom makes what he believes is the most perfect formula card in the history of formula cards. And then Adam, of course, has the most perfect formula cards ever. I say, please compare your cards. And you know what happens pretty close to 100% of the time?
Mine is always better.
No, the other person has something on their card that you don't. That every single student who's done this has told me, oh my goodness, I'm so glad I did, because I left the formula off and I didn't even realize it until I looked at their card. And the same thing, that you made this perfect card going through your stuff, but it's really easy to miss something. You forgot to write one down. And you know, Murphy's Law, the one you forgot to write down was the only one you truly needed. or you wrote it down incorrectly and you looked at their card and went, oh my goodness, you know, I have a plus and it should be a minus, or, you know, something like that. So I don't mind people comparing formula cards. I think it's wise in this environment. I don't know how easy it would be for you guys to do that, but I think it's still wise. Or you just simply, you know, what are you putting on yours? And then you have this list of things. Again, I don't think you could fill up one side of the page, but you know, any theorem, formula, definition that you don't know off the top of your head, you don't feel absolutely certain. You know, I don't think you need to write down the integration by parts, you know, uv minus v du. But when's the last time you did one? So maybe you write that one down. But what other kind of things? How about things like center a mass? Does anybody remember how to do a moment? I mean, you haven't done that in a while. There are a few things that you haven't done in a while, even if you did them well, that it might be wise to write it down. Again, it's theorems, formulas, definitions, not an instructions manual, but the things that you might blank out on in the middle of an exam. Oh gosh, was it this or was it that? You know, it would be wise. I don't need you to have formulas. I don't need you to have formulas at all. And not everybody does on every test. Only about maybe 3/4 of the people do. Okay. Now I'm going to stop recording. If you guys have any questions, this